Good evening, everyone. I request Kevin sir to conduct the session. Kevin sir,
Good evening, ma'am. Good evening, sir.
Kevin sir, excuse me, sir. Kevin sir, are you there, sir?
Good evening, dear students.
Good evening, sir.
Hello. Good evening, dear students.
Good evening, sir.
Okay. We'll begin the today's class. So we'll begin with the parametric form of the equation. A parametric form of parametric equation of a straight line. What is parametric? Last time itself, when I was teaching you regarding the concept of transformation of not transformation of axis, locus and so on without it. Even when we are doing especially with regard to locus, we learn this one. Each equation can be represented by a parameter. We also learned the parametric equation of a circle, parametric equation of a, what is this called as ellipse, hyperbola. So any equation can be expressed using a parameter. Now, today we'll be learning this parameter or its parametric form of this straight line. Through which parameter we are going to express this straight line? How this x comma y can be expressed in some other parameter, etc. That we are going to study now. Now, this is my x and y axis, and there is a line. Let us say there is some line L. There is some line L, and is passing through a point. Let us say is passing through a point Px comma y, normal arbitrary point, and is also passing through one more point. That the given point x1 comma y1. Px comma y is an arbitrary point that we consider for ourselves, whereas my point A x1 comma y1 is a given point. This line is as I got an inclination, therefore there is an angle theta because of this inclination with x-axis. Means when a straight line is passing through the point x1 comma y1, the straight line is passing to the point x1 comma y1 and making an angle. And making an angle, then the equation of the line is given by x minus x1 by cos theta is equal to y minus y1 by sin theta. X1 by cos theta, x1 by cos theta is equal to y minus y1 by sin theta. This is the equation line in when the line is passing to the point x1 comma y1 and is making an angle theta. So, dear students, now this is the equation of the line. Using this equation of the line, we have to find the parametric form or parametric parameters of this my straight line. So what is the parameter we are using it here now? Usually the equations we are doing with an let us say with an x comma y. The parameter that we'll be using here is, let us say, a parameter called R. What is that R? Let us see. Same thing, I am going to consider my straight line as line L is passing through the point y1. And this is the point we are considering an arbitrary point x comma y. I will take this the distance between A and P. The distance between A and P, I'll take it as R unit. This distance I'll take it as R unit. Then what happens? Then what happens? The equation will become like this: x minus x1 by cos theta equal to y minus y1 by sin theta will be equal to this distance. So we are wondering why is x minus x1 is by cos theta as y minus y1 by sin theta is coming. Huh? Carefully. Line is there, a point px1 or y1 is there, and the angle theta is there. That means m is equal to tan theta. That means my slope I am getting for this line, and passing to the point, equation of this line is y minus y1 is equal to m into x minus x1. Yes or no? This is equal to y minus y1 is equal to m into x minus x1, where my m is equal to tan theta. Tan theta can be written as sin theta by cos theta. Y minus y1 is equal to sin theta by cos theta into x minus x1. Cross multiply. So what happens? y minus y1 by sin theta is equal to x minus x1 by cos theta. So we are getting this equation. You may be wondering why is getting. We are getting this equation with the help of point slope form. Each slope which are finding y2 minus y1 by x1. We are finding
Sir, your voice is cutting.
and this is equal to the distance between them. And this we know if B is equal to C means A should be equal to C, then B should be equal to C. From this concept, what happens? Cos theta should be equal to R, and my y minus y1 by sin theta should be equal to R. When we simplify this one, we are getting x minus, when we simplify this one, we are getting x minus x1 is equal to R cos theta. X minus x1 is equal to R cos theta. To simplify much more further, my x will become x1 plus R cos theta. And this will become y minus y1 is equal to R sin theta. So this will become as y is equal to y1 plus R sin theta, where R is my parameter, where R is my parameter. And what is this R? R is the distance between the any point on line, or the distance between the any point on line with general point x comma y. Or the distance between the any point on the line with the general point x comma y. So what is my parametric equation of the circle? My parametric equation of the circle is equal to x is equal to x plus r cos theta, and y is equal to y1 plus r sin theta. You understand the parametric form or parametric equation of the straight line?
Yes,
Hello,
sir.
students.
Yes, sir.
Yes, sir.
Okay, now we'll proceed with the same concept. By chance, what happens when my parametric equation of this of this line has got 2 points? This, let us say, I consider my point here. This is my A point A, x1 comma y1. I am considering 2 points, 2 arbitrary points, x comma y. One more I am considering it as uh, x comma y. Let me take this also as x comma y. So what will happen for this one? How do we get parametric equation for this one and this one? Equation for px comma y is how much? What is the parametric equation for qx comma y? Same thing. That means what point px comma y and qx comma y, both the point. Now when this type of condition is there, what will be my parametric? What is the parametric equation of the triangle?
X is equals to x1 plus
So
Don't know.
we should find for AQ and AP, then we need to
Pardon?
add the both of them.
Can't get you.
Yeah.
Is there something?
So we should, I think,
Possible.
so we should find QA and AP, and then we should be add both of them. Is it right, sir?
Yeah, that is also okay, but why you go so much complicated?
Sir?
Point in is in
Sir, your voice is
relation.
breaking, I think, sir.
One division, external division. Is dividing this one is dividing this only. X is equal to x plus x1
what is here, sir?
theta. X y plus y1 sin theta. Okay, R is there, no R. And for Q, I will take as for Q, I will take it as x plus x1 R plus theta minus y1 R sin theta. So it is going behind the point. Yes or no? How?
Yes, sir.
So we take a general point in two way bisecting a line, point x1
Proceed,
comma
sir.
y1. Then the parametric equation will become x plus x r cos theta plus y plus y1 r sin theta. X minus x1 r cos theta r is y minus y1 r sin. So to generally like
Excuse me, sir. Kevin, sir.
general r cos theta y equal
Excuse me,
to
sir.
plus or minus r.
Sir,
This
your
is
voice is
called
breaking, sir.
as
Your voice is
parametric
breaking, sir.
equation of straight line.
Sir, your voice is breaking, sir.
Sir, voice is breaking, sir.
Is it okay? Hello.
Yes, sir.
Yes, sir.
So generally we take the x is equal to whether it can become, we don't know whether it is coming front or backwards. Sir, we don't know whether the point is coming, when it comes front of point means no problem. We are getting it as a plus. If you are coming it is backward means we are taking minus. So generally, irrespective of appearance of this point px come p and q, that is a point or a base point. Irrespective of the position of P and Q, I take generally the parametric equation of a straight line is equal to x1 plus r cos theta, y is equal to y1 plus r, sorry, plus or minus r sin theta. Is it understandable for everybody?
Yes, sir.
And one equation, the equation will be equation of x1 by, remember we just now we derived this equation. The equation that we just now. The what is this called as the equation of that one will be written as x minus 1 equal to y minus
Sir, your
sin
voice is breaking, sir. Yes, sir.
equal to r. So x minus x1 cos theta is equal to y minus y1 by sin theta is equal to r. Is it clear, dear students?
Please,
Is it
sir.
clear?
Kevin, sir.
No. Hello.
Yes,
Yes,
sir. Sir,
Okay.
your voice is frequently cracking, sir.
Pardon?
Your voice is frequently breaking.
Just a minute. Okay. Just 1 minute, please.
Yes, sir.
Hello. Am I audible now, dear students?
Sir, you're
Yes,
audible,
sir.
sir.
Yes, sir.
Okay. Just a minute now. Now next we'll go to the next concept.
Sir, can you please repeat the previous one?
Pardon?
Can you repeat the previous parameter?
Okay. The parameter is x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. This is the equation of the line using parameters. The parametric equation of straight line will be x is equal to x1 plus or minus r cos or cos theta. Sorry, x1 plus or minus r cos theta. That is equal to y is equal to y1 plus or minus r sin theta. This is the parametric equation of a straight line, irrespective of the position of my point. Irrespective of the position of my point, whether it is ahead of the point or behind the point. Irrespective of the position of the point P and Q, the parametric equation of the straight line. Irrespective of the position of the P and Q, the parametric equation of the straight line is equal to x is equal to x1 plus or minus r cos theta, y is equal to y1 plus or minus r sin theta. This is called as parametric equation of the straight line. And this is known as the symmetric form of a straight line using the parameter r. This is called as the symmetric form of a straight line using the parameter r. Or else you can simply call, if you forget the concept of symmetric and so on, you can simply also remember that is equation of a straight line using the parameter r. So our parameter here is r. What is this r? R is the distance between this point, the given point or arbitrary point. Whereas I is the distance between any given point on the line with the point Px, y. Now we will go to the next concept. Is the point of intersections or positions of the line. Point of intersections or positions of a point in the line, or positions of point in the line. Here we'll be learning a lot of theorems. And a lot of corollaries also. Among this, there are two very important theorems are there: Sevet's theorem and Manco's theorem. So please listen carefully. So before going to those theorems, we will learn some basic theorems regarding this point of intersection and points of position of the point. Now, Let us say, let us say this is my x-axis and this is my y-axis. There is some line. By joining point A and point B. This is my point A. This is my point A and this is my point B. Let us say point A has some x1 comma y1 and point B has x2 comma y2. So I am getting a line by joining 2 points x1 comma y1, x2 comma y2. There is one more line. There is one more line. Let us call it as L1. Let us call it as let's call that line as L. I don't want to call it as L1. This line, let us say this line's equation as ax plus by plus c is equal to 0. This, now there is one line AB which is joining the points ax1 comma y1 plus byx2 comma y2, and there is one more line ax plus by plus c, such that this line is intersecting or dividing this line AB in the ratio. Let us say some ratio it is dividing. We have to find this ratio of this line. At what ratio this line is dividing? Let us take that as some. Let us take that equation. Let us take it as it is dividing the ratio k is to 1. But generally, now I have to find this value of k. In what value of k it is dividing this line? You understanding the concept? There is a line joining the this one A. I am getting a line by joining these 2 points A, x1 comma y1 and b x2 comma y2. There is one more general equation line ax plus by plus c. This line is dividing or intersecting or cutting or anything. This line is dividing this line. The ratio from k is to 1. And I have to find out what is this ratio k is to 1 or what is this ratio k. So you know that. Let us take this point of division as now point P. This point of intersection we take this point P. So a line is dividing in the here. This line AB is divided in the ratio at point P in the ratio k is to 1. Is it internal division or external division?
Internal.
It is an internal division. Therefore, point P's coordinate will become what will become ax2 plus 1x1. Yes or no?
Yes, sir.
K plus 1,
K plus 1.
comma
Ky2
ky2 plus 1y1 by k plus 1.
Yes.
Now, since my point P, look carefully in the diagram, my point P is lying on one more line. What is that line? Ax plus by plus c is equal to 0. Yes or no?
Yes, sir.
That means Px comma y is lying on the line ax plus by plus c is equal to 0. Means my line has to satisfy this equation. Yes or no? My point Px comma y has to satisfy that equation. What is my Px comma y? Px comma y is so much. That means my equation will become a into kx2 plus x1 by k plus 1 into b into ky2 plus y1 by k plus 1 plus c is equal to 0. Did you understand?
Yes, sir.
Now I take the LCM. What is the LCM? LCM is k plus 1. So I'll take the LCM and I'll cross multiply. So left out is equal to kx2 plus x1 plus b into ky2 plus y1 plus c into k plus 1 is equal to 0. That means I have taken the LCM, I have done fraction addition, and I have cross multiplied that k plus 1 on the other side. Is it okay?
Yes, sir.
Now I split my x2 and x1 terms separately. So if I split my x2 and x1 terms separately, what happens? akx2 plus ax1 plus bky2 plus by1 plus ck plus c is equal to 0. Yes or no? Now
Yes,
take
sir.
all the k terms together, and that is k terms is together, and leave all the other terms together. Means k terms is always with x2 or y2 is there. So a k x2 plus b k y2 plus c k plus ax1 plus b y1 plus c is equal to 0. Now keep all these things one side, send all these other things on the left hand side or right hand side. That will be, what is common here? K is common. ax2 plus by2 plus c is equal to minus of ax1 plus by1 plus c is equal to 0. So I have taken the entire thing minus as common. So I want the value of k, because k is the ratio in which the line is dividing now. K is equal to minus into ax1 plus by1 plus c whole divided by ax2 plus by2 plus c. That is, what is my k value? K is equal to minus of ax1 plus by1 plus c whole divided by ax2 plus by2 plus c. That means my line is dividing in this ratio. Still we are not yet over. I'll draw that line for you. Just a minute. I'll draw this for this. I'll draw the diagram what we draw in the beginning, what we do in the beginning. So there is my line A and B. This is my x1, y1. This is my x2. This is my x2, y2. And there is my general line cutting this line. The ratio k is to 1. That is ax plus by plus c. Do you remember yesterday we discussed one concept? That is, if my line is here and somewhere point P is here, x comma y, and this line equation ax plus by plus c, then the distance is given by what we are doing. We are putting this point to the equation, yes or no? Do you remember yesterday we discussed this theorem? That will be, we are applying this point to this equation. Then the equation is becoming what? The equation is becoming ax1 plus by1 plus c. So same thing, if you look carefully, see here. Here what we are doing, we are applying first point to the equation, and we are applying second point to the equation. Yes, look carefully here. If I am applying first point to the equation, it is becoming ax1 plus by1 plus c. And if I am applying second point to the equation, it is becoming ax2 plus by2 plus c. That means the ratio in which my line is dividing will be minus L1. That is applying 0.1 to the line, and L2 applying 0.2 to the line. So the ratio in which my line is dividing, that means if this is my line, L ax plus by plus c is equal to 0, and from x1 comma y1, x2 comma y2. So let us take for example 3 comma 2, and let us say some 7 comma 4. This my line ax plus by plus c is equal to 0 is dividing this line in the ratio some k is 1. That means it is dividing in the ratio as L of 3 comma 1 by L of 7 comma 4 in minus ratio. Do you understand how the line is dividing this or how the line is intersecting or dividing that line joining 2 points?
Yes, sir.
Do you understand, dear students?
Yes.
Hello. Is it clear? If you say yes, we can proceed to the next theorem.
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Now, let us we'll learn one corollary for this one. We'll learn one corollary for this one. That is, my line, general line, AL is equal to AX plus BY plus C is equal to 0. My general line L is equal to, my general line equation AX plus BY plus C is equal to 0. And this line has got only one point, AX1, Y1. This line has got only one point, X1, Y1. Listen carefully. If this line, if this point lies in the origin, that means let us say some line is there, AX plus BY plus C. My line is, my point is lying somewhere on, let us say, towards the origin side. That is, towards the origin side is this side. Then this point will be, if I multiply C into some constant into for this point, this L1, that is this point, let us take it as X comma Y. This that means this line of X comma Y, if I multiply with some constant, will be always greater than 0. And the same thing, if my line has got a point opposite to origin, which is opposite to origin, which side will come? This is my origin. Opposite
Left.
origin will be which side?
Left side.
Left side. That is, origin is here, towards the origin, opposite origin will be this side. That means if I'm getting a point somewhere this side, the point, if I multiply with something with my point to X2, Y2, this point will have less than 0 with this some constant. Don't worry, you will understand this concept when we discuss what is this called, another theorem. That time there will be using that diagram. When we discuss there, you will understand why it is greater than less than. Since it is a corollary, there is no much proof for this corollary. It is only a statement like the result of the theorem. From the theorem, we are getting one result. What is that result they are telling you? Is if I consider a point towards the origin side and if I am multiplying with some constant, then that is greater than 0. And if I am considering the point away from the origin, that is opposite to the origin side, then it is considered as, this can be this side also, this point can be this side also. That time the concept will be less than 0. Is it clear, yes, students?
Yes, sir.
Now we will learn one more very important theorem. That is, non-parallel lines. Two non-parallel lines. Let us say L1 and L2, or let us say L1, let us say this is my L1 and this is my L2. Is it let us say some word I will take it like this, L2. If you look carefully, my L1 and my L2 are non-parallel. It is not parallel. It is not even perpendicular also. Correct, no? So I am considering two non-parallel lines. Non-parallel lines. That means it is not parallel lines. And the point of intersection of these two non-parallel lines, if I take my line L1 equation as AX1 plus BY1 plus C1 is equal to 0 and AX2 plus BY2 plus C2 is equal to 0. Then the point of intersection of these two, what is this called as a line is given by, okay, I'll teach you the theorem. Then I will, what is this called as I'll explain you the shortcut of this theorem. It is given by B1C2 minus B2C1 whole divided by A1B2 minus A2B1, comma C1A2 minus C2A1, comma A1B2 minus A2B1. This x1, x2 is this is supposed to be here A1, A2, B1, B2. Just not, I'll write that again. This one. Just a minute. We'll change the color. Also, we'll change the thickness also. So my line is, this is my line, and there's one more line here, L1 and L2. That is A1x plus B1y plus C1 is equal to 0, and A2x plus B2y plus C2 is equal to 0. So first I'll teach you the shortcut of this theorem. Then you can go for the expansion of this theorem. It will be very easy. The shortcut I'll teach you. Point of intersection. Point of intersection. This I write in the form of matrices, determinants. That is B1 C1, B2 C2 whole divided by B1 A1, sorry, A1 B1, A2 B2. That will be, this is my x coordinate. My y coordinate will be A1 C1, A2 C2 whole divided by A1 B1, A2 B2. So if you simplify this one, or else if you expand this one, expand the what is called as determinant, you will get it as B1 C2 minus B2 C1 whole divided by A1 B2 minus A2 B1. That will be easy, comma. Yeah, this will be again A1 C2 minus C2 A1, A1 C2 minus C2 A1 whole divided by again A1 B2 minus A2 B1. The point of intersection of two non-parallel lines of the equation A1x plus B1y plus C1 is equal to 0 by and A2x plus B2y plus C2 is equal to 0. The point of intersection is this one. So if you find it difficult to remember this one, at least remember this determinant. It will be very easy for you to remember this determinant. B1 C1 B2 C2 by A1 B1 A2 B2, comma B1 sorry A1 C1 A2 C2 by A1 B1 A2 B2.
Sir, I think you have read wrong, sir.
The same, the proof of this one we did already in, let us say, the locus.
Sir,
That is point of intersection we did on one problem with the method of table multiplier table. Remember, in the locus we did one problem on intersection of a line and point of intersection we found out.
I think, sir.
The same concept is applying here.
Sir,
We find the slope and we take that as slope in the equation alpha, beta, a, b and c exponents, then multiply it. You get a
Second,
unknowns.
you wrote
Then
wrong,
when
sir.
you simplify that unknowns, we'll get it in a
Sir.
determinant form. If you refer back the notes on exercise, sorry, level 2 or level 3, not level 2, I think level 3 we did this problem in a locus. I
Kevin,
still
sir.
remember we explained this concept and Bhavan also has having the same doubt on this one.
Sir,
Hello.
Sir,
Yes.
you have written wrong, sir, here.
Well,
A1 minus A1 C2 minus C1
can I get
A2.
you? Hello.
A1 C2 minus C1 A2, sir, it will be.
Yeah. Okay. A1 C2 minus A. No. A1
See,
C2 A1. C1 A2. Okay. Now we'll learn one more corollary with regard to this same thing concept. Let us take two parallel lines, L1 and L2. Let us take two parallel lines, L1 and L2. Equation of parallel lines is given by AX1 plus BY1 plus C is equal to 0. AX2 plus BY2 plus C is equal to 0. The constant will be the same. The two parallel lines L1 and L2, AX1 plus BY1 plus C is equal to 0. AX2 plus BY2 plus C is equal to 0. So that is, for this, we know that parallel lines will never intersect. Yes or no? Why do we call
Yes,
them
sir.
as parallel lines? Parallel lines will never intersect, but we can consider a common point between them. Not common point, a point existing between them. Let us say a point can exist here, a point may not also exist there. How you to find out whether a point will exist between these parallel lines, somewhere here or somewhere here or somewhere here or somewhere here? How to find whether the point will exist between two parallel lines or not? Let us say point P x1 comma y1. Does my point P x1 comma y1 exist between these two parallel lines? I have to find out. How to find out? That is found out by the ratio ax1 plus by1 plus c all divided by ax what is called as ax1 plus by1 plus c2. That is, I am applying the constant of this two, this one to this one. That is, sorry, I am writing the wrong equation here. Ax2 plus by2 plus c. When I take the ratio of this two, if my ratio is positive, then there is a point existing between them. If my ratio is a negative, then there is no point existing between these two parallel lines. This is one of the corollaries that we are deriving from the concept of a position of a point in a straight line. That means when two parallel lines are given, ax1 plus by1 plus c1 is equal to 0, sorry, c is equal to 0, ax2 plus by2 plus c is equal to 0, then a point x1 comma y1 may exist, may not exist. And how to determine whether it is existing or not? By the condition that when you take the ratio of these two lines, the ratio has to be a positive value. If the value is positive, then the point is existing between them. If the value is negative, then the what is called as the point does not exist there. Is it clear, dear students?
Yes, sir.
Same thing. If I consider a line and a point, that's a line. Let us say if it is this one, let us say whether it is this line or that line. whether my point, any line, if you take that like that or also no problem. If you take like this also no problem. A general line ax plus by plus c is equal to 0. Both the line equation is a general equation ax plus by plus c is equal to 0. This line equation and this line equation. If a point, let us say ax1 comma y1, if it is lying above or below, how to find out? Same thing. I have to apply that point to the equation. I'll take it as some dot one. That means dot one means nothing but applying that point to the line equation by value of b. Same thing here also. Apply that dot one to the value of b. If my this ratio is greater than 0, then the point is lying above. If this ratio is less than 0, then my point is lying below the line.
Sir, can you explain once again what is meant by LC.1 and LC.1 here?
Hello.
Sir, can you explain once again what is meant by LC.1?
L.1.
L.1, sir.
L.1 is nothing. L.1 is what I am telling is just a minute. Wait. Instead of writing the entire x1 comma y1, I am taking two this one, whether it is like this line or like this line, any line. Whether point is lying above or below, whether my point is lying above or below. Point is already given by x1 comma y1. Yes or no? X1 comma y1. Again, the point is given by x1 comma y1. So we have to find out whether this point is lying above or below. Then that concept, how to find this one? The line equation is equal to ax plus by plus c is equal to 0. So put that point LP, the point x1 comma y1, and divide it by the y coordinate b. If this is greater than 0, then my point is above. If it is less than 0, that is my when I apply the point x1 comma y1 to the this one and to the b, if it is less than 0, then this is below my line. Are you understanding?
Yes, sir.
Since this is a corollary, of course, proof is there, but since it's a corollary, what I prefer is let us not spend much time in proving the proof of these corollaries. Just only the results, since these are the results of the theorems what we are learning of previous one. So the statements are very important because we'll be using these statements in solving the problem also. Also, mainly we'll be using some of these statements in some theorems to prove that theorem. So with this, we'll stop. Tomorrow we'll start very important theorems like Sever's theorem and Manakov's theorem and so on. And with that, we also spend some time on concurrency of the line and so on. If possible, tomorrow itself we'll start the centers of a triangle using line. Ortho center, in center, x center, centroid and so on. Or else we'll discuss it on Friday. So please, dear students, today we have learned lot of new things. Point of intersection, parametric form, symmetric form. Please go through with the corollaries. So as I told, straight line concept is very important with regard to your both JEE main and advanced. At least you will get 2 questions. That means you are getting almost 8 mark from this chapter itself. So kindly don't lose that 8 mark. We know what is the importance of one single mark in IIT exams and so on. So a very important chapter which carries 8 marks only from this chapter. Both mains and advanced. Advanced I'm still not sure because of this year we have not got the weightage of advanced syllabus. Main syllabus weightage you have got already. One of these days, once this straight lines is over, I'll share that file with you. So you'll understand each chapter how many weightage is given. We'll stop it here, dear students. So we'll meet tomorrow. Kindly please go through whatever we have discussed in the class, mainly the concepts of these theorems and so on. Or else, when we are solving the problem, you will be what is called, you will be you will be like Alice in the Wonderland. Having a lot of doubts and so on. So kindly do spend time learning the concepts. One of these days, I spend only one class asking the questions on this thing. Okay. Thank you. We'll meet tomorrow.
Thank you, sir.
Thank you, sir. Advanced Teachers Day.
Students, you've got a class again in the morning tomorrow. All right.
Advanced
Good
Teachers Day,
night.
sir.
Yeah, thank you so much. Thank you so much. Is it Navneet?
Yes, sir. Neet.
Yeah, thank you so much, Navneet. All right, see you tomorrow, students. Bye, everyone.
Thank you, sir.
Mr. Divya, did you get the notes?
No, sir.
Okay. Acha, Divya, and what are the topics you are asking for chemistry, man? Is it periodic table or chemical bonding?
Periodic table, sir.
All right, all right. I'll take care of it.
Thank you, sir.
Most welcome, Divya. So, bye, everyone.
Arun sir,
Yes.
can you send the notes in the group also?
Yeah, I'll send to everyone. Yeah.
Okay, sir.
But let me just, I'm waiting for the notes to reach me. Once they reach me, I'll send forward to everyone in
Okay,
the
sir.
group itself. In the group itself. Bye, everyone. Good night and good luck.